Hello everyone, welcome to this walkthrough of the Newton's Axiom project. This is a game jam entry for the 72-hour GMC Jam 7. It's basically a small asteroids-based game with fleet building, mining, and an open world system. What I had wanted to do in building this game was to explore this kind of steering behavior, also known as Boids, based AI. So all of these units are controlled by steering behavior rather than finite state machines, which was an interesting challenge and resulted in some nice looking unit movement. So as you can see, it's a very organic movement. Just generally feels more like an organic fleet rather than very robotic movements that you might see with finite state machines and more basic methods. The mining units themselves, this mining behavior where they go between the mothership and oops, I've just transferred into a fighter by accident. Come back. Okay. This behavior that they have where they alternately go mine and then shuttle the goods back to the mothership, that is also steering behavior, and it's simply done with an extra rule to the Boids, which I'll show in a sec. So without further ado, I will go through the project. The majority of the action in the game takes place in this one room called RM Game. And when you open it up, you'll see in the top left corner a bunch of controller objects. So we have the save load controller, the player controller, the effects controller, which contains most of the particle effects, the cursor controller, spawner, and some UI elements. The other rooms are things like the menu, so simple new game continue menu, have a game over menu, and the init room, which is basically empty and is only responsible for running our init script. So let's look at what I think is the more interesting part of the project, which is the way I've implemented the AI. So as I've mentioned, this uses Boids rather than state machines, and I'll link a tutorial for Boids in the video description. So each of the classes of ship in the game is parented to a single parent object called object spacecraft. And you can see in the children's list, you have every class of the object. And each of these has further children. Sometimes this frigate, for example, is just a simple variation on the destroyer. And I also have the enemy versions of these units. And they just have the same behavior, but a different sprite. For example, if we go to the enemy frigate, you can see that it has no unique code. It has a different sprite, and I believe it also has a few different variables to define its behavior. For example, we have, I think, a slightly slower max speed, so you can outrun the enemy. I believe that's a slightly slower fire rate, and the turret is the red version of the turret. That's simply a sprite selection. And this system lets me reuse all of the events from its parent object, the destroyer. So in the spacecraft event, step event, we have the Boid code. These are the Boid weights, and this controls how strongly each of the Boid rules affects the eventual vector that we calculate. And so we have Boid rule 1, fly towards the center of mass. This keeps all of the units together in sort of a flock, basically. Rule number 2, which is to avoid each other and the asteroids. If you set this to 0, then basically the units won't avoid each other and will eventually clump up together, and will also fly into asteroids. Maintain group velocity rule. This is an interesting one. This is what's responsible for making the motion more flock-like, rather than individuals who are sort of trying to aim for the same location. We have a couple of other rules which are specific to the player fleet. One is to follow the player controller. So when you're in your mothership or any other ship, all the other units will try to follow you. which is very important because there's no other way to control where these guys fly. And we have one more, which is the mining. And this only applies to the miners, and this is a rule that causes the mining units to fly towards mineable objects and also shuttle their goods back to the mothership. And we have rule number 6, which is charge at hostile, so it makes all units fly towards an enemy that is nearby. Once this vector is calculated, we calculate the move, amount, and direction, and that's fed back into the movement script, which is relatively straightforward. It's acceleration, force and acceleration based movement, some simple F equals ma down here. Other than that, we have some collision code. So this collision implements sort of a little bit of physics. It implements circular collisions. So to quickly demonstrate the voids, what I can do is I can say, let's not avoid any units or asteroids, and see what that does to the behavior. So right now they are not avoiding anything. So as you can see, all of the units bunch up together into the same location because they're all trying to head towards the same point, and eventually they'll all end up above the unit. And I think if I can fly around here, you can see that they're kind of haphazardly bouncing off the asteroid because they're not trying to avoid it. So if I close that, take that back to what it was before, 0.3. In fact, let's go with 3, so it's now 10 times more strong of a rule, and run that again. And you'll see that they will, once they finish attacking, let's give them some help. They're actually struggling to attack because they're not able to fly towards the enemy as easily because they keep repelling each other. So we can generate a few more ships and see what happens. So they're trying to get towards the asteroid, but they can't quite make it because they're being repelled by it. So again, they're all trying to fly towards me at the moment, but they form this kind of circular shell around me because they can't get close to each other enough to do it. The miners are also struggling, but they also have a very highly weighted rule to head towards me. And so even though they're being repelled, that's being counteracted by that other rule. And you can see that they're struggling to land on the asteroid because they're again being repelled by the asteroid. Again, counteracted a little bit by their minor rule, which makes them head towards asteroids, but it's a bit more challenging. So these are the kind of rules that you can tune using the void system to make the fleet behave more like a fleet. So that's how I've implemented voids. Check out the tutorial that I've linked below, and that should hopefully get you up to speed on how voids work. Let's talk about the user interface in this game. This game has a very simple user interface. In the main game room, we have 6 buttons, 1 to build each of the 6 ships. In the menu and the game over screen, we have buttons as well. Each of these buttons, it's its own object. So here you can see the different menu buttons and the different build buttons, but they all parent to one object, the object UI button. This object is responsible for dealing with clicks inside itself and also for drawing itself to the screen. As I mentioned before, I use the room editor to lay out the UI, and what that means is in the create event, I grab its room coordinates, the X and Y coordinates, save them, and I draw them at the GUI instead of the regular draw event. So in the draw GUI event, I have draw sprite to this save location. In the draw event, I have nothing. This disables its regular draw. So in the click section of the step event, when we detect a click inside the button, we run this code, script execute action script, action argument. These are variables that by default are set to no one and -1, meaning there's nothing assigned to this parent button, but they are assigned by the children. Each child object will have its own script and arguments. The build buttons themselves also have an additional functionality. They calculate their tooltip text based on the resource requirements of the ships, and they'll draw the ship sprite as well. But other than that, behave in very much the same way. They will check whether there are enough resources to allow the ship to be built, and also define what ship is built. And so that's the user interface. The game has an open world procedurally generated universe, which, if you think about it, is a bit weird calling it both a world and a universe. But anyway, the object that deals with this is the virtual object, or the controller object spawner. And what this object does is it detects which block you're in, and each block is about 2000 by 2000 pixels. And when you enter a new block, it despawns all the blocks that you are far away from and spawns in some new blocks. And this object always maintains 9 spawned blocks, the one that you're in, and 8 around it. So the code calculates which block number you're in, and if you are not, or if you've changed blocks, it does the despawning and spawning. And the way it does that is it calculates the bounding box of the 9 blocks that you're in right now, and anything outside those blocks gets despawned. This is a version of culling, but instead of deactivating the object so that you can reactivate later, we just despawn it, because there's not really anything special about these objects. We can spawn in new ones later. They're not unique in any way. And once it's done that, it calculates which new blocks need to be spawned in, and then simply spawns them in. The script SCR spawn block is responsible for generating that block, and it will do a couple of things. Firstly, it will calculate the resource availability, and this is done with some math. I don't quite remember why or how I've done it this way. I can see that this is a LCG, pseudo-random number generator, so I assume at some point I've created a spreadsheet and worked out what these numbers need to be to make a reasonably random or deterministically random resource count for the block that it's in. And it takes in the current X and Y block coordinate and calculates the resource, and it should be random but deterministically so. So every playthrough you get the same set of random numbers. This makes each game somewhat predictable. So if you wanted to, you could map out the universe and figure out where all the high resource blocks are and just stick with those. But I don't think anyone actually wants to do that. And the same goes for the hostility. So each block has a hostile count, and the more hostile a block is, the more enemies there are in it. Once those variables are calculated, we go and check our game data for whether the resource mines are already spawned. And the resource mines are the only thing that is tracked in the game, in the save game. And this means that you can't just reload your game and mine some new mines. You actually deplete the resources that you discover. And this, in theory, forces the player to go further and further away from the center, which should become more and more hostile. So this code maintains a map of lists which contain the X and Y coordinates of the blocks. And here we generate the new mines. If it's a new block, we spawn the enemies based on the hostility. The higher the hostility, the bigger the enemy groups get. And that's really it for spawning a block. In addition to spawning the block, we also have further asteroid and unit spawning, and this is just on a timer. This prevents the user from clearing out the enemies in a block and then just sitting there to mine. Instead, we start throwing asteroids and enemy units at the player on a timer. And the more hostile the block is, or the more dangerous the block is, the shorter that time it gets. And really, that's it for the procedural generation. So that's all of the unusual or interesting aspects of the code. I encourage you to poke around and see what you can find. I apologize in advance for anything that's unusually implemented. There was a very short amount of time to build this project. So thank you very much, and I'll see you next time.